Almas. My name is Oleg.
And it is our physics project. Enjoy the video.
Okay, so in this video, we'll be discussing about rotational motion, torque and equilibrium, oscillation, and waves. So let's go to the first chapter, that is rotational motion by me.
Rotational dynamics. When an object moves in a straight line, then the motion is considered as a translation. But how if an object is moving along in an axis in a circular path? Well, it is known as rotational motion. In linear motion, an object is moved till it feels any external force, but when an object is moving about a fixed axis in a circular or curved path, then it can also feel the force, better known as a torque. The first thing that we have to know is angular acceleration. It is denoted by theta. It is a ratio between the arc length and the radius of the circle. The next one is angular velocity and angular acceleration. The rate of change of angular displacement is called angular velocity. The next one is angular acceleration. The rate at which angular velocity changes with time is called angular acceleration. The next one is rotational dynamics equations. There are three rotational dynamics equations. The first question is, this is rotating with a constant angular acceleration of p radian per s square about a fixed perpendicular axis which is passing through its center. A. Find the angular velocity of the disk after 4 seconds. B. Find the angular displacement of the disk after 4 seconds. C. Find the number of turns accomplished by the disk in 4 seconds. Now, let's see the solution. Question 2. A boy rotates a disc and the disc starts rotating with a constant angular acceleration of p radian per s square about a fixed perpendicular axis which is passing through its center. A. Calculate the angular velocity of the disc if the time given is 8 seconds. B. Calculate the angular displacement of the disc if the time is 8 seconds. C. Calculate the number of turns accomplished by the disc if the time is 8 seconds. Now, let's see the solution.
Enough with the first chapter, now let's move on to the second chapter, that is torque and equilibrium, that will be discussed by Almas.
Rigid equilibrium. But before that, there are conditions of an object reach the equilibrium. The first one is the net force of an object in all directions must be zero. It contains the Newton's second law. In the form of an equation, this first condition is written like this. As said before, the force in all directions is zero, so the external forces along the typical x-axis and y-axis must be zero. This is written as right there. Here's an example of the equilibrium itself. As we can see, we stand on the ground. The second condition is the net torque in the object in all directions must be zero, and it can be written as like this. Here's an example of one question. A board mass 2 kilograms used to play seesaw by 2 kids, A and B. A mass 30 kilograms and sit 2.5 meters from the center point. How many meters must B, whose mass is 25 kilograms, sit so that the board is stable? And we can assume that the board is homogeneous and the G is 10 meter per second square. The answer is because a seesaw never goes to right or left, only up and down. So, we don't need to look at the x-axis. All we need to do is look at the y-axis. And we can found it is x is 3 meters. So B must sit 3 meters from the center point.
So that's chapter 2. Let's move on to the next chapter, that is oscillation, that will be discussed by Miftahul.
Let's talk about simple harmonic motion. It's an oscillation under retarding force proportional to the displacement from equilibrium position. You can project the motion in the time graph and you'll get a sine wave, like this image. So we can derive the displacement equation as a sine function, and we get the formula, like this. The oscillation has phase. It also has a potential energy, and here's the formula. Also the kinetic energy, and mechanical energy. Every oscillation has period, and here's the formula. And let's go to the problem and let's break down the solution. Here it is. And here's the solution. First, the point A, we can substitute time equal 2 seconds to the displacement equation. Next, we can find the velocity by differentiate the displacement equation. Point C, we can find the acceleration by using the second derivation of displacement equation. Point D, E, and F, you can solve it by using this formula, like period, frequency, and phase. Well, that's it. Back to you, Arfi.
Next, move on to the last chapter, that is waves. The first part of the waves will be discussed by Alif, and the second part of the waves will be discussed by Lentera.
The next part is mechanical wave. There are 3 types of mechanical wave. The first is transversal wave, longitudinal wave, and surface wave. And we can look the difference of the wave. The first is transverse wave. In transverse wave, particles of the medium vibrate up and down perpendicular to the direction of the wave. So move to the second wave is a longitudinal wave. In a longitudinal wave, particles of the medium vibrate back and forth parallel to the direction of the wave. The last wave is surface wave. In a surface wave, particles of the medium vibrate both up and down and back and forth, so they end up moving in a circle. So next, move to the mechanical wave equation. Currently, wave equation is y equal a sin cross omega cross time plus minus constata cross by x. And we can get constata by 2p over by lambda. We get omega by 2p cross frequency. And we can look to the picture. It explains about velocity, lambda, and period. And move to the example question. A wave running to the surface of the water meets the equation y equal half sin p cross 100t minus a quarter x, y and x in meters and t in seconds. The wave velocity is, and let's go to the solution. The first step is determine in a phase the frequency of the wave. Frequency equal omega over 2p equal 100p over 2p equal the frequency is 50 Hz. And the next step is calculate the wave length. lambda equal 2p over constanta equal 2p over a quarter p equal the lambda is 8 meters. And the last step is calculate wave velocity. V equal lambda cross frequency equal 8 meter cross 50 Hz equal the wave velocity is 400 meter per second. And it's all the part 1 of the mechanical wave.
And now we are moving to the second part of the mechanical waves. And the first thing that I want to explain is about wave interference. If we have two pulses in here, then what will happen when these pulses overlap? Let's just find out. If I take one and I move this here, and then another wave's gonna move over the top of that one, I'm gonna get the wave interference. This is the term wave interference for when two or more waves overlap in the same region. So what's gonna happen? Well, the string can be in two places at once. There can only be one string and one shape of that string. And the way you find out what the total wave is gonna look like is simply by adding up the contributions of the two waves that are overlapping. And now, what about standing wave? Standing wave is a wave which appears to be vibrating vertically without traveling horizontally, created from waves with identical frequency and amplitude interfering with one another while traveling in opposite directions. Now let's move to the example of the standing wave. As we can see in the picture, the wave has an equation pi together with 0.2 cos 5 Vx sin 10 Vt, where the y and x in meters and t in time. And the question is, the distance between sequential antinodes and the nodes of this wave is. Let's try to solve this one. As we can see on the picture, the distance between the sequential nodes and the antinodes is the same with the quarter wave. So we have to find the length of the wave. Well, k is 2v per lambda, where we can swap the lambda and the k, lambda to the other side, where lambda is 2v per k. We can put the k to the equation. K is 5v, where we can get the lambda is 2v per 5v, where it is equal to 0.4 meters. So we can find the distance between the antinodes and the nodes, where it is the quarter of the lambda. A quarter multiplied the 0.4 is equal to the 0.1 meters. And that is the answer.
Thank you for watching our videos. Please click the like button and don't forget to share the video.
See you next time!